Like I said, in this tutorial, we are going to be talking about variables. Like we know, there are different types of variables defined with different keywords. For example, we have the int variable. The int variable, normally it stores integers, whole numbers without decimals, such as 1 to 3 or negative 1 to 3. So like first of all, we're just going to list the variables, all of them, but we're going to start with the basics for us to understand more. So we have the int, we have the double, we have the char, we have the string, and we have the bool. So these are the kinds of variables that we normally use and will be using in the daily basis when we'll be writing a C++ program. And they are very powerful sources to be using when writing a C++ program. So first of all, we want to start when we declare or when we create a variable. Normally, the syntax is always, you normally give it a type and then the variable, or we could call that the identifier, and then we assign it a value. So like, for example, we could say we want to declare a variable with an integer type. We could say int name is equal to Felix. Not really, not int, but okay, let us use string, because, or let us use int number for us to understand. Int number is equal to 24, right? Then all statements in C++ programming, normally they end up with a semicolon. Now, as we can see, the int is the type, the number is the variable, and of course the equal sign, and that is an assignment operator which we'll learn in the future. And then we do have the number, which is 24. This 24 is not the value that we would assign to the variable. So when we go down, we find that like I just said, so the type is just like I've explained. Now we want to create a variable called my number or my name, which already we have created. So we want to output that number. Yeah, so when we output that number, it is supposed to be giving us an expected value of 24. As you can see, when the compiling stops, it should be giving us a value of 24, and let's just give it some time. And it's taking quite a long time. And here it has finished the compilation. So like, as you can see, the errors are 0, warnings 0, but now when we want to output it, let's just see, it should be giving us the value 24 here. Actually, we are using the console window to output our programs, and we will be using that throughout these tutorials. For example, we could declare a variable double. Like I said, double, it stores floating point numbers with decimals. It stores floating point numbers with decimals, such as 19.99 or negative 19.99. Now we want to see how double comes into our code. Let us just comment this one. So we would like to see how double comes out in our code. So like we'll just use the same procedure again. We will say double number is equal to 34.99, isn't it? Now we want to so when we output the number and we compile, it should be giving us and the compilation is done. When we try and run it, it gives us 34.99. We could do that with a string, we could do that with a bool. So the third variable we have is char. Char, it stores a single character such as A or B. Mark it, single characters. Char values are surrounded by single quotes. So we will do that too. And we say char F. It should be stored in single quotes. Rather, char name is equal to F. Not really name but letter. You can use anything that you want, even your mother tongue. Doesn't really matter when you're defining a name of a variable, as long as you can understand it. So there we could say cout name. We will compile our program, and then after compiling our program, we are going to run it. So when we run our program here, it gives us letter F. Now, as you can see, it tells us about something like single quotes, and it also says it stores a single character. Let's try storing more than a single character, more than one character, and we see the reason why it stores only a single character. So if we say Felix and we compile again, this time round, it is gonna generate a compilation error. Why? It tells us character constant is too long for each style. That is why we cannot use more than one character when declaring a char variable. When you want to use when you need to use more than one character, you declare it with the string. So we could say string name is equal to Felix, isn't it? Now in this scenario, let us just comment that. Let us comment this one. Just rectify it for a moment, and boom, it's done. So that's it. So we're going to use string when you want to comment like more than one character, you use a string. So we'll say string name is equal to Felix. Now the difference between a character and a string is that a string is stored in double quotes, whereas a character is stored in a single quotes. Let us see now. We want to see out name and see what it's going to bring to us at this time round. When we try and run it, as you can see, it gives us Felix there. Yeah. So we also have another variable which you call bool. Yeah. So we also have a bool variable. I'm just commenting them so that you might use them later in your references. A bool type normally stores variables in two states, either true or false. Okay. So this is what is going to happen here. So for example, we could say bool condition is equal to true. We want to see how it's gonna work for us. We are going to echo, not really echo, sorry, I'm confusing that with PHP, but no offense. So we will say cout condition. Yeah. So when we compile this our program, and after compilation we run, actually it gives us a 1. That is where now it becomes so interesting. Remember, it stores values in bool, binary, either true or false, either 1 or 0, or either yes or no. If we could say that bool condition is false and recompile it again, it should be giving us like something else. It should be returning to us 0 now. It returns 0 to show that the condition is false. Yeah. So we're going to talk much about how we could declare multiple variables. Actually, there is a way we could declare multiple variables, and we could use them if you see like declaring int A, int B, int C. If it becomes more tedious, we could just do something like this. We could just say int A is equal to 5, B is equal to 11, and Z, or rather C, is equal to 15. Yeah. These are the way we could also declare the variables. Now, when we want to perform a mathematical function like add these numbers, we could just say cout, like we want to output like the sum of all these 3 variables. We could just say cout A plus B plus C. when we compile this program and wait for the execution, when now we try to run, it outputs 66, meaning that it is addition of a plus b plus c. This just proves to us that we can declare a variable of the same type in one line and in multiple forms. Now the next we are going to talk about identifiers. Like in our past work from the beginning, we talked about something like, we did talk about something like int a is equal to 22. Now this is an identifier. When we say string name is equal to Felix, this name is an identifier. Now, in short, we could say all C++ variables must be identified with unique names. These unique names are called identifiers, or like I've just told you about. Identifiers could be like short names like X and Y, or like more descriptive values like age, sum, or total volume. And it is also recommended to use descriptive names in order to create an understandable and a maintainable code as a programmer. For example, like let's take about, for example, this. Here we have something like int minutes, then we gave it 9. If you check this code, if you check this statement here, this statement is like someone can understand it very easily. But if we decided to give the same thing like int m is equal to 9, yes, all of them they are correct, but now the first one here is easier to maintain and understand than the second one. So like we recommend you that when you are creating identifiers, you use more descriptive values so that when it comes to maintaining and reading your code, the programmer gets an easy time in doing that. So we also have something to do with the rules we could use for constructing names for variables. For example, we could say names can contain letters, digits, and underscores. Names must begin with a letter or an underscore. Names are case sensitive. Names cannot contain white spaces or special characters like exclamation mark, hashtag, percentage, etc. Reserved words like C++ integers such as int, float, char cannot, and I repeat, cannot be used as names. The next thing, or rather the last thing that we're going to talk about variables is the constant. When you do not want others or yourself to override an existing variable value, use the const keyword. This will declare a variable as constant, which means unchangeable or read only. For example, we could say const int number is equal to 27. Now, what I've just declared here, number will always be 27 and can never be changed. If we try and declare the same name and give it, for example, a value of 9, so we could say number is equal to I. This, when compiled, is going to generate an error. Yeah. And what is the error? Assignment of read-only variable number. But what if we remove it and we compile again? It is not going to bring for us any error. You should always declare the variable as constant when you have values that are likely to change. For example, a number like pi. As we all know, pi cannot change, so it is good to declare such numbers as constant. So like we could say const int minutes per hour is equal to 45. Yeah. And we could say again const float pi is equal to 3.14. This is a valid way of declaring constants. You're gonna love this. So we will meet again in our next tutorial, where we are going to be talking about the user input. Thank you very much, and we shall meet in our next tutorial. Bye. Hello, welcome back. Today we are going to learn about C++ user input. You've already learned that cout is used to output print values. Now we will use cin to get user input. As we know, cin is a predefined variable that reads data from the keyboard with the extraction operator. In the following example, the user inputs name, then the program simply is going to say hello with the name that the user inputted. Like in the last tutorial, we learned about variables, and we said that variables, they store values, isn't it? So for example, let's look at this example in user input. What is your name? Felix. When we output that, it says hello Felix. What about when we say what is your name? I will try to run and we say John. When we output this, it says hello John. So actually the syntax of writing this, normally it's just something like cin, then the identifier of the variable, isn't it? So that is all. So our next program, we are going to write a program that is going to prompt for two numbers and is going to input the sum. It's going to output the sum of those numbers. So this is the program. We'll say int x int y, isn't it? So we are going to say cout input x, and then we'll say cin x, then we'll say cout input y. then we'll type something like say in y. Then we are going to perform now the mathematical addition, whereby we will say cout the addition, or rather we could say the sum of the two numbers is, then when outputting we leave two less than signs, and then we say x plus y. We're gonna learn about that. Then we end our statement with a full stop. Now when we try to compile this program and wait, it says there is an error somewhere. Actually, yes, there is an error somewhere. I forgot, sorry. There should just be x, y. So when we compile again and we try to run, it says input x, I will input 34, I will input 3, input y, I will input 4. Then it says the sum of the two numbers is 7. Quite explanatory, right? So that is all the basic about user input. Thank you for watching, and we'll meet in our next lesson. Thank you. Welcome back. Today we are going to talk about data types. As explained in the variable chapter, a variable in C++ must be a specified data type. For example, we could have something like int my num is equal to 5, or we could have something like float my float num is equal to 5.99, or we could have something like double my double num, which will have a value of 9.98, or we could have something like char my letter, which will have a value of f, or we could have something like bool my boolean, which should have a value of true, or we could have string my text, which could have a value of hey. Yeah, so this is it. Int my num, float my float num. Int my num, actually it stores whole numbers, as we talked about last time. Float and double, the two of these ones, they store floating point numbers. And we have char my letter, which stores one character, and bool my boolean, which stores the variable in two states, either true or false. And we have string my text, it stores a collection of characters to form a string. So as you can see, those are the data types, and we are gonna talk about how we could use each one of them. First of all, we are going to start with the numeric types. Yeah, actually these ones we use int when you need to store a whole number without decimals, like 35 or 1000, and float or double when you need a floating number with decimals, like 9.99 or 3.14515. For example, for an integer, we could say something like int my num, like we said here, int my num is 5. When we output this, and we compile it, and as we wait, we try to run it, it outputs us a value of 5, meaning it only stores integer values. If we try to declare a floating point there and we compile, as you can see, it's going to compile without an error, but when we try to run, just outputs 5. Yeah, because we declared the variable type as an integer. So that is all about integer. We have the float, also the same, like I have explained all of them. Now here we've seen float and double, and we want to see how they differentiate each other. The precision of a floating point value indicates how many digits the value can have after the decimal point. The precision of float is only 6 or 7 decimal digits, while double variables, they have a precision of like about 15 digits. Therefore, it is safer to use double for most calculations than float. Actually, a floating point number can also be a scientific number with an e to indicate the power of 10. For example, we could say float power is equal to 35 E3. Yeah. So if we try to output power, it should bring for us something like that. As we wait as it compiles, then we try to run, it brings 35,000. Yeah, meaning it has been in power 3 with 3 zeros. So if we put -3 and try to compile it again, then during that time we try and run, then it tells us 0.035. yeah, so that's all about the numbers. Next we'll move to something known as the boolean. Yeah, for the boolean, a boolean data type is declared with the bool keyword and can only take the values true or false when the value is returned. And all of us, actually not all of us, sorry, but if you are new, normally when the value is returned true, it could be 1, and false, normally it returns 0 during the output. Why do I say this? For example, bool, my boolean, as we declared here to be true. So this is what we are going to do. We are going to output boolean, my boolean. Yes, actually let us comment out this one. And yeah, some error, I never placed a semicolon, sorry. So if we try and compile it again and we run, it tells us 1. You can see it has returned 1. What if we give my boolean value to false? What will it give back to us? Let us see there. Yeah, it gives us 0. Quite interesting, yeah. So that is it. We could also say like something. Yeah, so that's all about the booleans. Next we'll move to the character types. Yeah, under character types, we have something like the char. I remember I was talking about the char. If you haven't having a good understanding, my English, forgive it. If you are not having a good understanding with the char, I advise you to go back to my variable tutorials and look at it again. So the char data type is used to store a single character, and the character must be surrounded by single quotes. For example, we say something like char letter is equal to B. This B is a character. Let us output it and see. When you output B that way, not really not B but letter. Remember, this has to go with this. Anything different from that generates a compilation error. So when we run this, actually it gives us, oh sorry, I never commented this, that's why it's bringing a 0 on the top there. So if we compile and we try to run again, it gives us B. Yeah, so that is all about characters. Alternatively, we could also use ASCII values to display certain characters. For example, we could say like char A is equal to 65, char B is equal to 66, and char C is equal to 67. Something like this. Let's see about this. Let us just comment this one out and say char A is equal to 65, char B is equal to 66, and char C is equal to 67. When we save this and we want to output all of them, and let's start with A. Actually 65 is the ASCII, or you could say ASCII, something like this. ASCII values, yeah, and I could say characters normally used also with ASCII values. Yeah, something like that, isn't it? Yeah, so like when we compile these and we try and wait for it to compile, then we run it. As you can see, it gives us A. Nice one. For example, we displayed that with B, compile it again, and wait until this is finished, then we run, it gives us B. Quite interesting. Yeah, and the same happens also with C. So next we are going to talk about strings. So we'll just comment this one out. Then we'll talk about strings. I'm commenting them this way so that it might help you during reference in case you are gonna save these. So string types. Yeah, so that's it. The string type is used to store a sequence of characters. Like I said earlier, this is not a built-in type anyway, but it behaves like one in its most basic usage. String values must be surrounded by double quotes. For example, we could say something like string greeting is equal to hello world, isn't it? Yeah, so when we try to see out greetings, we'll see something like this. we compile and it tells us that there is no error, and boom, when we try to run that, it tells us hello world. So that is all about this. Next we have to continue here, and let me just mention something. Now when we are using strings, you have to include an additional header file in the source code. If you're not familiar with the header files, I would advise you to go back to my introduction tutorial and see how it works. So we will include something like this. This is the header file. So the second one we would say hash include string. Actually, this will help us in writing the program easily during the manipulation of strings. That is the basics about strings. Next, we want to move to the advanced of strings. So that's it, but that is going to happen in a later tutorial, not this one. So let's meet in our next tutorial, where we are going to be talking about some very powerful features known as operators. Thank you, and I hope you had a good time. Thank you and goodbye.